Let's talk a little bit about the drafting tools we use when we look at engineering drawings. We generally have a scale and we have some sort of protractor. The scale is for measuring distances and the protractor is for measuring angles. So here we have a typical engineering scale. It's a small one, but it's triangular and it's got a different scale on each edge of this scale. On one side here we've got a 10 scale and a 50 scale, and when we flip it over we've got a side with a 20 scale and a 40 scale, and when we flip it to the third side we've got a 30 scale, and oftentimes there will also be a 60 scale on this side. Now for our tools with our right-of-way association manuals, we use just a flat scale which has on one side a 50 scale, and there's also a metric scale on the same side, and on the other side we have a 10 scale and a 20 scale. Now the way we use a scale is in measuring things on maps. Since our maps can't be drawn at true size, they have to be shrunk to a size that will fit on the appropriate piece of paper. We have an example here. Will typically show us a scale, and on this one we see 1 inch equals 100. Now that tells us that we need to look on our scale and find the 10 scale, because the 10 scale is going to be used for any map scale that is a multiple of 10. So it could be 1 inch equals 10, 1 inch equals 100, 1 inch equals 1,000. Any scale like that, we're going to use the 10 scale. Now there's one thing that's important to recognize with the 10 scale. It's divided into inches. You see 0, 1, 2, 3. But differing from a ruler, which divides inches into quarters of an inch and eighths of an inch and sixteenths of an inch, a scale divides inches into 10 parts or 100 parts. So here we see on our 10 scale 1, 2, 3, 4, 5. So halfway, a half inch is 5 marks, and then 5 more makes an inch. And that works when we're trying to scale multiples of 10, because we can just say, if we're talking about 1 inch equals 100, we think about 1 inch equals 100 feet. Means down here at the 1 mark, which is 1 inch down, that will be 100 feet, and each of the small marks will be 10 feet in between. So if we look at the map, the project map we have here, we said it's a 1 inch equals 100. So we find the stationing on the project of 0 plus 0, 0, 1 plus 0, 0, 2 plus 0, 0, which should be 100 feet in between. And if we lay our 10 scale on here, we will see there's 0. I lined up with the 1 plus 0, 0, and there's the 1 at 2 plus 0, 0. So that confirms this is 1 inch equals 100 feet, and each of the small marks in between will be 10 feet. If we look at another map here, this one is at 1 inch equals 20 feet. So on our scale, we're going to find where it says 1 inch equals 20, and here's the 50, and here's the metric, and here's the 20. So 1 inch equals 20 feet, we look on here to find the 2, and on a 20 scale, that's actually not 2, that would be 20. So 1 inch is 20, a half an inch would be 10, and each of these small marks in this case would be 1. So if I wanted to scale on this map, we have a pipe going underneath the center of a creek here, and they label this pipe as 28 feet at 1 inch equals 20. So I can lay my 20 scale on here, and I'll line it up right there where the 28 is, and I put the 0, and there's 10, there's 20, there's 25, and it takes me right over to 28. So that shows that in fact this is a 20 scale. So if I wanted to scale, for example, how long this piece of pipe is along here, it's labeled 70, but let's just see what we get. If we lay our 20 scale on here, we'll line it up at the bottom here, and we come forward 10, 20, 30, 40, 50, 60, and we get right to 70. So that length of pipe would be 70 feet, and in fact that's what they show on the drawing here. Okay, our other drafting tool is a protractor. And protractors come in a lot of different shapes and sizes. The one that we use with our Right-of-Way Association courses is a circular one, and it has an arm that moves. And the purpose of a protractor is to measure angles. And with our protractor here, we can actually determine what bearings are. Bearings are a type of way to designate an angular direction in surveying and in legal descriptions. Bearings are described by either north towards the west or north towards the east, or south towards the west and south towards the east. Now a circle has 360 degrees in it, so each quadrant of the circle has 90 degrees. So when we talk about bearings, a bearing that would be in the northwest quadrant would be described as being north, a certain number of degrees towards the west, followed by west. So if I was to look at this problem here, I will lay my protractor so that the north is oriented right up this axis here. I put the center of the protractor right in the center of the angle, like this. So I've got my north-south axis in the protractor laying right over the top of the north-south axis on the drawing, and I move this arm over until it's laying right over the top of that line. And then I can read up here, north, 10, 20, 30, 40, 50, looks like about 54. So that would be north 54 degrees west. That would be what that bearing is. So when you look at that, one of the interesting things about a bearing is no bearing can be more than 90 degrees, because a due west line would be north 90 degrees west. And it also is the exact same bearing as south 90 degrees west. But you can see that you would not have a bearing, for example, of north 95 degrees west, which would put you down here actually in the southwest quadrant. So what we might want to call north 95 west would properly be south 85 west. So you cannot have a bearing that's more than 90. We can try this on this next little axis here. So again, let's orient our north-south axis on the protractor with the north-south axis on the drawing. We put the center of the protractor right on the center there, and we swing this arm around until it's going right down the angle that we want to measure. And then we read the angle. In this case, we're in the southeast quadrant. Bearings always start with south or north. They don't start with east or west. So we would say south, and we measure around 10, 20, 30, 40, 50, 60, looks like about 69 degrees to the east. So that bearing would be south 69 east.